Okay, today we're going to work with some more disc and washers. So I'm going to look at this first problem that I'm given here, and it says find the volumes of the solid generated by revolving the regions bounded by the graphs of the equations about the y equals 4 line. So I need a picture of what's going on. What I'm going to do to get this picture is I'm going to just plot some points. So if I plug in 0, I get 0. If I plug in 1, I get 1/2. If I plug in 2, I get 8 divided by 2 is 4. And so here's my curve. I'm only concerned about it from there to there. It says from the x equals 0 line to the y equals 4 line. X equals 0 is the y-axis here. We're going to revolve this about this axis. The area that I'm revolving is right here. I'm going to go ahead and put a little rectangle standing for a section that I would be revolving about the y equals 4 line, so I can picture in my mind what shape that would be. And if I'm revolving that about the y equals 4 line, I end up getting a disk. So I know that I'm going to be working with pi and then r squared. This is a dx problem, so I'm going from 0 to 2, and I can see that because I'm changing right here from 0 to 2 on the x. And this time, since I'm revolving at about the y equals 4 line, I have to take top minus bottom. That will allow me to find this area between the two curves. So I need to say it's 4 minus 1/2 x cubed dx. And this whole thing is squared because it's pi r squared. So now I'm ready to FOIL this, which gives me 16. This will be minus 4x cubed plus 1/4 x to the 6th. Integration will give me 16x minus x to the 4th plus this be x to the 7th over, I'd have a 1/4 out here in front, over 7, and then I'm going from 0 to 2. Gives me the answer of 32 minus 16 plus 128 over 28 minus 0. Subtracting this gives me 16. Making a common denominator would give me the answer of 144 pi over 7. So I'm jumping those steps. You guys can work through the common denominators and such to come up with that final solution. Alright, getting started with this problem, I'm going to be revolving about the x equals 5 line on this problem, which makes it a little bit different than what we've done. I have a line that starts at 5 and has a slope of -1. So it looks like this. I'm going to be revolving about the x equals 5 line. I have the x equals 0 and y equals 0 lines. So those are the axes that it's bounded by. And then I also have one other line here, the y equals 4 line. So the region I'm talking about is underneath black line, the blue line, and then to the right and above the green lines. And I'm going to be revolving that about the x equals 5 line. I have to decide what shape this is going to create. Since I'm revolving it about the y, or the x equals 5 line, I'm going to take a small piece of it. So I always like to draw that little rectangle on there so that way I can see, okay, what shape am I ending up with? And this would be a washer. You can see that because I have a hole right here that's created when I'm revolving it. So that would be my little r. And then my big R would be from the farthest side here to the line. Alright, so my volume ends up being a washer, so I know it's pi, and it happens to be a dy, so I'm going to go from 0 to 4. It would be a big R squared minus little r squared, and it is a dy. Since this is a dy, I need to create or rewrite this function in terms of x equals. So when I solve for x equals, I get 5 minus y. So down here, I'm going to go ahead and figure out what big R and little r are. Big R, since we're revolving at about this x equals 5 line, happens to be, I have to always go right minus left. When I have a dx, I always go top minus bottom, but on the dy's, I go right minus left. So I have the 5, x equals 5 line, and the x equals 0 line, so I just simply say it's 5 minus 0, or just 5. The little r goes from the 5, the x equals 5 line, to the 5 minus x line. Well, in this case, I need to say 5 minus y because I needed to have this in terms of y. And so that makes my little r be 5 minus 5 plus y, or just simply y. So I'm going to come back up to this problem and start rewriting it. So I've got big R squared minus little r squared dy. So when I go to integrate, I end up getting 25y minus y cubed over 3 from 0 to 4. So when I plug in my numbers here, I end up with 100 minus, this would be 64 over 3, minus 0. Making a common denominator, I'd have 300 over 3, and 300 minus 64 is 236 pi over 3. I'm going to go ahead and stop here and just do the whole problem, the next problem on it, on one video. Alright, this is my last example from the section on discs and washers. Finding the volume of the solid generated by revolving it about the x-axis. So let's draw a picture of what's happening. I'm going from x equals 0 to x equals 6. So I'm only going to concern myself with that part of the graph. So when I plug in 0, I end up with 2. When I plug in 1, I end up with 1. When I plug in 2, I get a 2/3. And I'm going to go all the way down here to 6. Well, when I plug in 6, I get 2/7. So just a very small, I'm not at 0, but I'm really close. Then it's also bounded by, so this is my x equals 6 line, here's my x equals 0 line, and then right here would be my y equals 0 line. So I'm talking about this region right through here, and try to highlight that just slightly so you can see that. This, when I talk about revolving this about that x equals, or this x-axis, what shape is this creating? Well, it's creating a disk. So I know my volume is going to be pi, the integral from 0 to 6 of r squared, and it's a dx problem. This one's pretty simple. Don't have to do a whole lot of thinking because the top function is the function that's given, the bottom function is 0, so if you subtract those, you just end up with that one function. So I end up getting 2 over x plus 1 squared dx. When I'm integrating this, I'm going to go ahead and square these. I get 4 over x plus 1 squared. I pull out my 4 out front just to make things a little bit easier. And I might even rewrite this as x plus 1 to the negative second power. You can create a u statement, but the u statement is not necessary because the du just gives you a dx. So you end up with just u to the negative second over negative 2. So I really don't need to make that u statement. What I'm going to do is just go ahead and integrate this. So I'll raise it by 1, and I'll put it over that negative 1, and I'll plug in my 0 to 6. So I end up with 4 pi times, so being negative 1 over x plus 1 from 0 to 6. So I end up with 4 pi times negative 1 over 7 minus a negative 1. So I change my signs to plus the opposite. I end up getting 6/7 on the inside, and I have 4 pi on the outside. This gives me my final answer of 24 pi over 7.